Hi, my name is Chad Clay, and today I'm going to be showing you how to do lesson 7.7 trapezoid approximation of area under the curve. And sorry, I have a cough still, so I might be coughing a lot. So, this is the graph of y equals x squared. The question is, what is the area under the curve from 0 to 3? Approximate using equal height trapezoids. Now, you could also see this question as the integral of 0 to 3 x squared dx use equal height trapezoids. Now, the College Board is going to ask either this question or that question. They both mean the same thing. Don't get tripped up by it. Now, to figure out this question, let's just do a little visual first. So we need to find the area from 0 to 3 under the curve. So I drew out 3 trapezoids to simulate that. So there's the first one, the second one, and the third one. And the area of these trapezoids should be an approximation of the area of the actual under the curve. As you can see, the lines are pretty close. So, how to solve this? So first, let's look at what an area of the trapezoid is. Area of a trapezoid is 1/2 times height times base 1 plus base 2. Now let's look at our x and y values real quick. So what I like to do to solve this is make a chart of our x and y values that are going to go in to the equation. So x is 0, y is 0. X is 1, y is 1. X is 2, y is 4. X is 3, y is 9. We all took Algebra 1 and we know how to do that. Now let's look and see how those translate into each of our equations. So our height, what is our height? How is it going to work out here? So the height is going to be the difference in each x value. So the difference in between x1 and x2 is going to be 1. The difference between these two x values is going to be 1, and the difference between these two values is going to be 1 as well. Sorry. So the height for all of these is going to be 1. Now the bases are going to be each of the y values. So base 1 is 0. Base 2 is 1 for that equation. So area for trapezoid 1 is going to equal 1/2 times 1 times 0 plus 1. Now let's look at the area for trapezoid 2. It's going to be 1/2 times 1 times 1 plus 4, because the y values for each of those are the bases. Now let's look at the area for trapezoid 3. 1/2 times 1 times 4 plus 9. And if you want a quick visual, let's go back here. See, the bases, see here's one base, is that y value of, or f of 2, that's one base, and then f of 1, that's the other base. And so if we add all of these areas up, you're going to get 19 over 2 units squared. Now, there's a shortcut for this. There's a formula, actually. Formula for area under the curve using trapezoids. So the area under the curve is going to be delta x, which is the height from before, the difference in x values, 1 from before, over 2, so that's just the 1/2 from the equation before, times f of x sub 0 plus 2f of x sub 1, so on and so forth until you have 2f of x x n sub x n minus 1 f of x sub n. Okay? So the explanation of this equation is, as you see before, let me bring this table back. The 1's here we're repeating, the 4's here we're repeating. So we could use that to our advantage. And that's what we do with these 2f of x's, 2f of x sub 2. So let's check it out. So our delta x for our original one was 1. So 1 over 2 times f of x sub 0, which was 0. 2 times f of x sub 1 is 2 times 1 is 2. Plus 2f of x sub 2 is 4 times 2. And then plus 9, which is our last one. So 19 over 2 units squared. And it works out. So let's look at another shortcut. This is kind of a mouthful, and I'm still coughing, so be aware. If your function is odd, example y equals x cubed, or a type of oscillating function, example y equals sine x, and the bounds absolute value are equal to each other. So for example, if the absolute value of -3 is equal to the absolute value of 3, or the absolute value of negative pi over 2 is equal to the absolute value of pi over 2, or the bounds complete a period. So if you have an oscillating function like sin was x, and your period is 2 pi, then the bounds 0 to 2 pi would work for this. Then the area under the curve is 0. So let's take a look at the graph so I can explain this. So here we have y equals x cubed. Okay, so from -3 to 3, Here's our area under the curve as shown in blue. Now, these areas actually look very similar. That's because they're basically the same area just flipped. So this is a positive area, this is a negative area. When you add these up, it's going to equal 0. Now let's look at sine x. Here we have 0 to 2 pi right here, as shown in blue. Now the area of this hump is going to be equal to the area of this hump at absolute value. So when you add these up, they're just going to equal 0. So there's one of the shortcuts you can look out for. So another problem that the College Board is going to give you is going to be a tabular type of problem. So they're just going to give you this table, no equation, no graph. And these are actually quite simple to do. So what you want to do here is look at the x values, look at your y values, and just do what we did originally. So trapezoid 1 is going to be 1/2 times delta x, which is 4 minus 1, that's 3, times base 1, 2, base 2 is 9. Do that, and then 1/2 times 1, because 4 minus 5, or 5 minus 4 is 1, times 9 plus 5, which is the two bases, that's trapezoid 2. Trapezoid 3 is going to be 1/2 times 7 minus 5, which is 2, times base 1, 5, plus base 2, 6. You add those up, you're going to get 69 over 2 units squared. So, wrapping it up, things to watch out for. Calculator errors. So, as you can see before, from our first problem, there's going to be a lot of parentheses that are going to go through. I have probably like 20 parentheses there. And there's going to be multiplication and addition. So what I would say is really look out for your parentheses. Those will trip you up, especially if you get into equations where you end up having like negative y values or pi or stuff like that. So that's going to be an issue. So watch out for calculator errors. Next is going to be the area and delta x, the delta x errors. So if we look back to this tabular problem, the delta x's are not equal here. So if you would have tried our formula from before, this one, and you just did a delta x times each of the f of x's, you would have gotten it wrong. Because the delta x for this one is not the same as the delta x for that one. So you have to actually individually add up each one until you get it correct. Our last error is misusing shortcuts. So if you're going really fast through the test and you see y equals x cubed, find the area under the curve. You'd be like, oh, it's an odd problem, it's going to be 0. But what if it's like -2 to 3? Then you're going to have that extra area under there. So that's going to be incorrect if you put 0 because the absolute value of the bounds are not equal to each other. The other thing you need to watch out for is using this formula. You got to remember the 2 times the function. If you don't do that, you're going to get the whole problem wrong. This 2 is very important because you reuse the bases each time, except for the last 2. So don't use it every time. Use it for the middle ones. Yeah. So, overall, things to watch out for: calculator errors, delta x errors, misusing the shortcuts. Thank you for watching.